Welcome back to the channel. Today I want to talk about this microcontroller and radio module that arrived. Go through its features and some of the issues that I found when trying to get it set up. So this is a pretty useful little module. It has an ESP32 on the back, which is the big brother to the ESP8266. So this does have Wi-Fi and Bluetooth. More importantly, it has 2 cores and a good amount of memory. The Wi-Fi antenna for that is this strange thing here. I read online that it doesn't have great Wi-Fi, but that doesn't really matter for us because we won't really be using it. On the front here we have an OLED display, which is very useful for displaying diagnostic information or once we have them sensor readings. You can see here the antenna that was provided. This is connected to a LoRa radio module, which I believe is the Semtech module. It's the 915 megahertz version, and that will be different depending on your region, so make sure to look that up. This also has lithium ion charging on the back. It came with this little connector here to plug into the back of the board right there, which you can use a small lithium cell and it will charge and be powered by that. So that's very useful. So when I connected this up with the software to connect to the Things network, and there is a gateway downtown just a few miles from where I live, I was unable to make a connection, which I believe means that the radio is unable to send packets that far, which could be a number of things. It could be that this antenna is not actually tuned to the 915 megahertz frequency. It could be I have set something up wrong, and it could also be that that is out of range for what these radios can do. So what I've done for the meantime, before I figure that out, is I've purchased another one of these. And for our early experiments, what we'll be doing is just doing point-to-point communications between the two. So for today, for this video, what I'm going to do is show you how to set these modules up with the LoRa libraries in Arduino and get them talking back and forth to each other. Okay, so here we have the sender. You can see the OLED on this one was somewhat damaged, so I guess it's only displaying every other line, but that's okay because on the sender we don't really need to show data. We mostly need to show data on the receiving end, so it should be fine. But you can see here I've put a label at the top so we know which one is doing what, and there's a packet count here. The actual packet that goes across the wire just contains a counter for now. It doesn't contain any other data. But that number, whatever it is in the packet counter, shows up on this side, and that's read out of the packet. And we can also see the RSSI, which it might be a little small, but that says -3, which is a very good signal. So small negative numbers are very good signal, and then large negative numbers are less good signal. But the antennas are incredibly close to each other, and also they share ground because they're both connected to the same USB source. So if I move that away, you can see the RSSI changes. Now if we jump over into the code, you can see that it's split up into a number of files. So the main file just decides whether we're running the sender or the receiver. This makes the directory structure easier. Otherwise you have to have 2 completely separate directories, and all the shared files are harder to share. The sender.h file just basically sets up the sender's init function and the sender's loop function for the setup and loop, and the same thing for the receiver.h. If we look at sender.cpp, This is essentially what would have been the main file for the sketch. We have our initialization, which gets a display, initializes the radio, and then draws the title on there. So the title is, in this case, since we're the sender, it's just sender. And then we have the loop, and since we are the sender, every 5 seconds we clear the screen, send a packet, and then update the display. And then at the end of that time we update the packet sequence. So there's a couple of methods that I have up here for doing all those little things. So we have a title method, we have a print packet method. Our initialize radio does a couple of things that we want to do. This is for diagnostic purposes. It sets up a display on the screen. So if initializing the radio hangs for some reason, or if it takes a long time, we'll see this in it. But the actual radio initialization happens in the radio dot CPP. Where is that? There it is. This sets up the pins for the radio. It begins it, and it also enables CRC. If we had more complicated settings, we would put them here, and this file gets run by both the receiver and the sender, so it's useful for that purpose. If we go back to the sender, at the top you can see we're also including display.h and packet.h. Display, the H file says which functions are exported. CPP is the implementation. So here we have a reset and an init. We don't actually call reset here. The reset, the OLED library doesn't actually handle resetting the display, so we have to do that manually with a digital write and all that. And display init handles everything that we need, and then returns a pointer to our display so that we can use it from each program. And then finally, for the shared files, we have packet.h. And what this does is it defines a struct which is used as the actual memory that goes over the wire. This attribute packed stuff just tells the compiler not to add any extra space in between the things inside of the struct. It would do that in order to make it easier to access them, so that they show up at memory boundaries at the right place for this particular chip. But since what we're really using this for is as a bag to put data in over the wire, we don't want any extra space put in there for convenience later, because we really want to send the fewest number of bytes over the wire as possible. So I have the packet struct here, which just contains a sequence, and then we also have this little packet size, which is just defined to be the size of the packet. So anyway, that's just a useful little convenience thing that I'm using in other places. So when we actually send data using this, all we really have to do is call begin packet to start sending a packet, and then we write data into that packet. We have to pretend that our data is a constant uint8t, which is basically just bytes. So we cast it, and then we tell it the size of our packet, and then we end the packet. And all the ifs that are around here are just error handling. So if we can't begin a packet, I return -1. If we can't end the packet, I return -2. And then written is the number of bytes that we actually did write, and that should be packet size. So that's what that method does. And then on the receiver side, when we initialize the radio, we also set up this onReceive. OnReceive is a function, which is just up here, that gets run every time we receive a packet. I did run into some interesting issues with this where I could not call any of the functions related to the display inside of this callback. And if I did, it would crash. So what I had to do instead is I just have this flag here, have new packet, and I set it to 1. And then in the loop, I check for that flag and then unset it. So if there's more things to display, then we display them, and we won't display it on the next iteration of the loop. I believe the reason for crashing in this particular manner is due to having multiple cores in this chip, and probably something about the multitasking in the real-time operating system that's actually running under the hood. It might actually work on a real Arduino. I'm not 100% sure. But yeah. Oh, it's also worth mentioning that there are 2 libraries being used in this code, which I will link in the description where you can get them. The first is an OLED display library, and I had to get a version that was specifically for this board. It looks like there are some differences that the manufacturer of the board provided a library, somewhat modified version of an existing Arduino library to use. And so I got that from a GitHub page that I'll link in the description that has information about this chip. Let's see, if we go to display.cpp, that's also where I got these connections from. And then for the radio, I'm using a standard LoRa module, but I'm using one that I found, I believe, on GitHub instead of through the Manage Arduino packages. It's just very slightly more up to date. I'm not sure if that was necessary, but that's the one I'm using, so I'll link to that one in the description. So the important thing is you need to run this set pins command because the pins are not always the same on every board. But other than that, the examples just worked out of the gate. You just had to add this particular line in front of them. And in case you're not sure what a CRC is, this is just a little bit of sort of safety on the packet. So it adds some metadata every time it sends a packet, and the CRC, it's kind of like a checksum or a hash or something. It's a bit of data at the end that tells me if there were mistakes in transmission. And the library is capable of handling that by default, which is pretty useful. So then if you want to actually burn this out, so right now we have sender uncommented, and I'm just going to upload it. Oh, I don't have the correct USB enabled. Alright, so now I'm uploading to this board here. That's initialized. And now if we uncomment receiver and comment sender, choose the other USB, we will upload the code, and then it is already in sync. Well, that's all for this video. I do expect to have these sensors begin arriving very soon, hopefully within the next week. It will take me some time to write code to show them off, but it will be enhancing this example, so it shouldn't take quite as long for the next video to come out. Anyway, thank you very much for watching. Please check out the links in the description if you have any questions, and feel free to leave me a comment if you see something obvious that I'm doing wrong. Thank you very much again for watching. Goodbye.